Solving real-world problems using algebraic reason. So, we kind of last time learned to put things into equations, so now we're going to learn how to solve these problems using more of reasoning than just being given the problems. So, after Donovan gives Mabel 6 pairs, she has x plus 6 pairs, because Donovan gives her that extra 6. Now, if Mabel gives 1/3 of her pairs to Nelson, how many pairs in terms of x does Nelson have? So she already has this whole thing, but she's going to give away 1/3. So if there are 3 parts of this, 1, 2, 3, each one is 1/3 of x plus 6, x plus 6, and x plus 6. Now, she gives this away. Given away. So she has this much. That means that we're going to add them together. 1/3 x plus 6 plus 1/3 x plus 6. So now, we want to see how many Nelson has. So that's how many she has. This is how many Nelson has. 1/3 x plus 6. So this we don't actually need to know to answer the question of this problem. So we have how many he has. Now we can just simplify it. So 1/3 distributed, 1/3 x plus 1/3 of 6 is 2, and that's our answer. Example 20 says, there are n apples in a box, but 5 apples are too green to eat. So there are n. Now 5 apples are too green to eat. Aaron and Barry share the ripe apples in the ratio 2 to 3. So if Aaron gets 1, 2, Barry gets, wait, let me make those even. 1, 2, Barry would get 1, 2, 3. So these are all the ones that are good to eat. And these two, we could say, are taken by Aaron. And these 3, we could say, are taken by Barry. So 2 parts Aaron, 3 parts Barry. So let's figure out, okay, if this total is 5, this total is n, Aaron plus Barry has to equal n minus 5, because we have the total minus 5 equals that whole thing. And now we know that each of them have different amounts of this 5 of n. So if using the bar model, we can figure out how many fifths they have. So Aaron has 2/5 of n minus 5. Barry has 3/5 of n minus 5. So we could write out the equation like this. Now, let's determine how many Barry has. So it already says here, figure out how many Barry has. He has 3/5 of it. So we can simplify it by distributing 3/5 of n minus 3/5 times 5. The 5's cancel. It becomes 3/5 n minus 3. Another method you could use is to do the whole thing mathematically, and you could just say ripe equals n minus 3, or sorry, n minus 5. And you would already know that, so then you could plug that in to this equation and get the same thing. Try this on guided practice 1 and 2. Example 21. We are going to solve a word problem using algebraic expressions. So one number is n, and a second number is 2n divided by 3 plus 2. So you can see they're related, they both have n in them. A third number, so this is number 1, this is number 2. A third number is n divided by 6 less than the second number. So we have to transfer the second number over. And it's less than that by n over 6. So that's our third number. Now express the sum of these 3 numbers in terms of n. So all we have to do is add them, and that gives us the sum, but we do want to simplify it. So this whole thing, n, we're going to transfer down, plus this one we can spread out. This one, well, it's addition, so we can just take those out of the parentheses. And we know that 2n over 3 is the same as saying 2/3 times n. And then we have here plus 2. This transfers down the same, and it would be n divided by 6. So n divided by 6 would be the same as saying 1/6 n. Now, let's add all these together. So first, let's put the like terms together. N plus 2/3 n plus 2 plus 2/3 n. Oh, sorry. 2 doesn't go there. Plus 1/6 n plus 2 plus 2. So we put these two numbers together. We put the algebraic terms together. Now let's put them in least common denominator, which here would be 6. So we would have 6 over 6n plus, both of these multiplied by 2 is 4 over 6n plus 4 over 6n plus 1 over 6n plus 2 plus 2. This equals 6 plus 4 plus 4 plus 1 over 6. That whole thing is n plus 4, which is equal to 10, 14, 15 over 6n plus 4. Oh, you know what I did wrong? This one is subtraction. Hopefully you caught that, and I did not catch it. So this whole thing becomes subtraction, so instead of 15, this number is 13, and that would match the answer in the book. So that's how that one's found. Go ahead and try that on guided practice 3. Hope that showed. There you go. Okay. Example 22. Now, there are an equal number of boys and girls in a group of 80 children. 80 total, boys equal girls. Within the group, P% of the boys and Q% of girls wear glasses. So P% of boys and Q% of girls. P and Q could be different amounts, but remember, boys and girls equals the same amount. So to figure out, we're going to write an algebraic expression for the number of children who do not wear glasses. Factor any terms with a common factor. So we already said the number of boys equals the number of girls, which would mean that each of them is the total divided by 2. Because equal boys equal girls, there's 80 total, so there must be 40 each. We know that. So we could say that P% of boys is P% of 40. Q% of girls is Q% of 40. So we know that one. Now to figure out the percent, instead of saying, okay, P%, we could say just the letter P divided by 100 times 40. Just the letter P divided by 100 times 40. There you go. This could also be written as 0.01 P times 40. 0.01 Q times 40. So multiple ways to write it. Now, we want to figure out the number of boys who do wear glasses. The number of boys that do wear glasses is this number. And 0.01 P times 40. We just multiply those numbers together, and that gives us 0.4 P. Do the same for girls. .4Q. Now, the number of children who do not wear glasses must be total minus girls who do minus boys who do. This is how we're going to find out. Don't wear glasses. So the total we know is 80. Girls who do are 0.4Q. Boys who do are 0.4P. And so this would give us the total number who don't wear glasses. It also said to factor, so we could factor out a number in this. We could factor out this number right here. So we could write that as 80 plus negative 0.4Q plus negative 0.4P. The reason we do this is so that we can factor out this number. 80 plus negative 0.4 times, on the inside we have Q plus P. Now we can always write plus a negative as minus 0.4 Q plus P. And this is our simplest term here. Try that on guided practice.